In the previous episodes, Halim and ET compared Nicole's method with Amir's method. In the last episode, they found two expressions that both represented the number of stones in the middle section of the cobblestone pattern. They saw that x times x plus x was equal to x times a quantity x plus 1. They know they're equal, but comparing these expressions was, as ET put it, very difficult to explain. Thinking about the mathematical ideas can be challenging. Sometimes it is useful to think about someone else's thinking other than your own to make sense of ideas. In this episode, Halim and ET will look at someone else's way of thinking about the expression x times a quantity x plus 1. Suppose your friend said, I think x times x plus 1 should be x to the second plus 1 because the dot means you multiply x by x, which is x to the second. Then you have 1 left, which you add. What would you say to your friend? Next, Halim and ET will respond to their friend's thinking by using the cobblestone context.
Halima, what do you think this is asking you to do?
I think this is asking us to use the friend's method and see if it works.
Okay, so you have to first decide whether your friend's correct or not. And then you need to develop what you're going to say to your friend. And whatever you're going to say should involve the drawing and the stones.
So in this equation, the x times x plus 1, it's different from x squared plus 1 because the x plus 1 is in parentheses first, which means that we need to go ahead and do that before we can do x times whatever the outcome is, because it will give us a different outcome, because x squared with this, the size number for this specific stone drawing is 5. 5 squared is 25, and that would be plus 1. That would give us 26 for our friend's new equation.
Like this?
Yes. Plus 1.
Yeah.
Well, our equation would give us 5 times 6.
Because we first solved for x plus 1.
Yes, which gives us 30.
Halim and ET are thinking like mathematicians. They first checked whether the expression x times a quantity x plus 1 and x to the second plus 1 gave you different results from a specific value of x. And they did. They know there are 30 stones in the middle section from their previous work. So their friend must have been incorrect. Next, they'll use the stone context in the drawings to show how they see the friend's way of thinking.
We would draw this.
And I'll draw for the other equation that the friend had came up. I think I have an idea.
We can both work on our ideas at the same time.
We might have different ideas.
Or maybe we think alike.
Maybe. Okay. Well, what I did is that I just took 5 tiles or 5 columns that have 5 tiles in them. So 5 groups of 5 times 5 groups of 5, which equals 25, plus just this one square added, just because that's just like the 1, which would equal 26. You kind of get what I mean, ET?
Yes. And what I did was I circled 5 columns with 5 tiles each, which gives us 25. And I think the way the friend would look at it was he would just circle this last column, but the last column wouldn't have any of these tiles left but that one,
Yeah.
like the same way Halima did.
So we do think alike.
Nice drawings. Halim and E.T. both drew how they saw the friend's incorrect reasoning. They showed how the friend saw x times x plus 1 as being equal to x to the second plus 1. Next, they'll explain how the friend was seeing the 1 in x to the second plus 1.
What do you think, Kalima? Where did the friend go wrong?
I think the friend went wrong thinking that 1 represented like maybe a whole column. Like maybe that's what he was thinking, or maybe that's what they were thinking, instead of thinking 1 just meant 1.
Yeah, so it's really interesting how the ones mean different things for each of these. In Halima's, the 1 means what? Is it a stone, a row, a column, or something else?
Just 1 stone.
1 stone. And what does the 1 mean over in the part that ET was working on?
1 column.
What do you think, ET?
Yes, I wrote it as 1 column that only has 1 tile.
Say that again, 1 column that only has 1 tile?
Yes, because I think that's how he was thinking about it.
Okay, instead of taking, how should he have thought about it?
He should have thought about it that each column has the same amount of tiles no matter what.
Both Halim and E.T. did a great job of explaining how they thought the friend was seeing the 1 in x to the second plus 1. Halima said that the friend went wrong by thinking that x times a quantity x plus 1 is equal to x to the second plus 1. We know they're not equal because, as Halima said, the 1 in x to the second plus 1 represented 1 stone rather than 1 column of stones. So, x to the second plus 1 could not represent all the stones in the middle section. E.T. said that the friend was wrong because he knows from before that x times a quantity x plus 1 is equal to x times x plus x, or x to the second plus x. So the friend should have multiplied x times x and then added the x number of stones in 1 column. Instead, he said that the friend saw the 1 in x to the second plus 1 as 1 stone in the column. E.T. and Halima had figured out that x times x plus 1 is not equal to x to the second plus 1. This is because the 1 in x times x plus 1 represented 1 column, and the 1 in x to the second plus 1 represented 1 stone. To get all the stones in that last column, we would need to add x stones, not 1. So now we have 2 expressions that are equal because they both represent the total number of stones in the middle section. Over the course of this unit, Halim and E.T. have developed so much meaning for their algebra expressions.